Thank you, Harishi. Thanks for providing us with the space and accommodating us with all the sound and light. And I know there was a little bit of distraction with the sound, but it eventually got fixed. So hopefully it will stay that way till the end of the event because my talk is there. So I want people to hear. Okay, so I'm very selfish about that. Is this the microphone? Okay. Okay, let's see, who's next? It looks like it's me. So I'll introduce my team and then we'll get going from there. Let me switch the PPT, 1 second. So before I start, is Harishji here? I don't see Harishji. I know one thing for sure, the food is here. So if you want to grab something, please do. 5 more minutes? Okay, I get a signal from Harishji, 5 more minutes. Food will be ready and we can get started soon. Okay, I know everyone is hungry after a day's work. So without further ado, let me introduce my team. Ron Majumdar, popularly known as Ron Arunava Majumdar, I'm the founder and CEO of ResearchNet. So we've been doing some of these events, mostly at the Microsoft Center. We'll have our next event at Microsoft Center again on April 2nd. Then the next one will be another, so we'll do 4 quarters. This is an extra one that we started because of this India Impact Summit, and thanks to Harish Ji and everyone, we could do it here. So, so I'm Ron. You can read up a lot about myself. I won't get into that. Diptam Mukherjee is still a student at Techno International, and he's gonna join ResearchNet as the head developer. So yeah, directly from college to, but he's been working with me for 3 years. So Diptam's on Zoom. He's in Kolkata, India. My son, Avi Majumdar, is here. He's been working on some sports AI applications, and he'll tell you more about it. Daria is here, my friend Daria over here. She's a professor at UIC, and we've been working on some very interesting things with her. So we'll talk about all that in a little bit, okay? So let's get started. We're already late, so I'm gonna skip over some of the slides, especially this one. No need to know more about me. Okay, what is open development? Open development is a completely open source effort, which I started way back when I was in IBM. I used to work for IBM for almost 24 years, well, 25 almost. Anyway, so we started an open development platform, and it is very closely linked to what we did at Center for Advanced Studies. And Jeff Terry is here. We've been working with him for a long time. I don't know how many years on a telescope project. So I do all kinds of weird, crazy projects, connecting telescopes or working with some AI tools or autonomous cars and things like that. Anyways, so that's what open development does. This is AI Alliance. So open development is actually part of AI Alliance, and thanks to AI Alliances, they're sponsoring the food and drinks for today. So Joe is here. Joe will be at the panel. I see Joe at the back. He's hiding over there. Okay, so I see Joe. Okay, let's move on. That's IBM Center for Advanced Studies. We have centers all around the world to work with universities and research. Well, I shouldn't say we, I left IBM, but anyways, it still feels like I'm part of it. Okay, ResearchNet. What are we trying to do? We're mainly trying to automate anything and everything that we can. So it's an automation platform. We're trying to automate process engineering, research. I'll get to more details about what we're trying to do and the pipelines. And then, of course, support and services. So if someone needs a custom solution or something using our software, we'll support them. Okay? So what is the problem that we're trying to solve? We don't have enough resources to do the job. We are always lacking resources. Quality of generated code is poor. Though someone here showed an application that actually works, many of the applications actually don't. Those that work, we should use AI for the rest of the world. There's us, okay? So contact us. Let's make it happen. Lifecycle management is not provided in many of the AI-generated stuff. So we do that, observability, testing, all that stuff we are providing. So these are the problems that we are trying to solve. And so this is our main use case. Say a scientist wants to do some research. He has to study lots of literature and eventually hire a few PhD students to be able to get to a point where the research can start. So can we improve that? Can we reduce the time through our AI pipeline? That's one of the main use cases that we are trying to do, because that is always a problem to me. So anyways, so rather than just doing that, can we also generate the product that can use that technology, and then can we support it? Okay, so I'll talk a little bit about this pyramid. Those who have come to my presentation has seen this multiple times. So unstructured code is chaotic. As we go up the pyramid, we have structured code, much better code, and at the peak is what I call pattern engineering. This is nothing new. This was started by the three amigos way back in, I'll say, the 80s, I guess, when UML and case tooling and all that stuff came. What we're trying to do is use the same technology along with AI to make it better and usable for any enterprise level application. So that's basically our use case. Okay, so anyways, I already talked about this. We're trying to solve all the issues and building a whole life cycle around it. Okay, so one of the key innovations that we're doing, it's a pattern engine that I wrote called Vortex Pattern Engine. This is a pattern engine like no other that exists. It's our IP. And this is a hierarchical, and it can generate basically anything. You can generate documents, you can generate code, you can generate deployment scripts, or even maybe in the future, we haven't been looking into binary structures, but maybe pictures as well. So the pattern engine is at the base of everything that we do. What we want to generate is deterministic NLP generation, as opposed to if you generate a code through an LLM today, every time you generate, there'll be slight differences, and we can't put that in production. So it has to be tested, and it goes through a life cycle again. What our tool will be doing is deterministically will generate what you need, and it'll use the pattern engine behind the scene as well. Okay, and this is what we're still working on. It's deep NLU research. So we are trying to understand what's in the literature, in the documents that are uploaded, and then convert that into structures that can be actually productized. So that's what the NLU pipeline is. Are we done yet? No. Then I could have shown you the demo and walked away. No, we are not there, but that's where the research is. The accelerator asset pattern, what that does is it creates a way that any of these applications that we generate can run. It's a runtime plus you can have development tools and all that stuff built on top of it. And we will eventually build some. Standard asset specification, what I mean by that is for every single thing that I do, whether it's script generation to database generation to anything that we generate, it's based on some specific specifications that we have created. And it's very, very extensive. and that is behind all the generation process. Okay, and again, that will eventually use the pattern generator. Reusable asset patterns. So once you can generate something, you modify it based on what you need. You put it as an asset pattern, and then you can generate more of it by varying the variants and what I call determinants inside that. So a variant and a determinant is pretty much the same thing, but determinant in my pattern engine is basically dependent on the generation process, which can change. Anyways, I don't want to get into too much technical details as I usually do and go down to code level details as people ask questions. We don't have time for that today, but I do want to show the new bot. Like every time we do some demos, so we can't do without a demo. It's a very short demo that our head of development, Diptam, did overnight, basically. So let's play that.
Let's do some research using our ODP research agent. First, we'll go to manage sources and type in the topic we want to search in archive. Let's search for black holes. Then we'll upload some PDFs from our local system so that the bot can refer to that. Once the documents are uploaded, we can start querying. Let's search what are black holes and send. Now the RAG pipeline starts processing the query and gathers answer using the relevant context. Once the answer is found, we can see the answer is backed with relevant sources cited after the answer.
So that's basically a RAG pipeline behind the scene. Plus we have our own innovation and stuff behind it. And to point this out, this has been running on a laptop end to end. So the UI is running on a laptop, the models are running on a laptop, the whole infrastructure, there's a database and all kinds of things. They're all Docker images. They're running on a single laptop with no GPUs, and it's still running. So Diptam's computer right now does not have a GPU. Mine, it'll run even faster because I have an NVIDIA CUDA libraries and all that fancy stuff. But so the other thing we wanted to point out is we are working on this intelligent agents that can route themselves. We haven't written much around that picture because we're still working on it. And wait till April 2nd on our next event 4.0, or we can call it 1.0, 0.4.0 or 1.0. We are trying to release the product. So hope to see you all there. This is no longer in presentation mode. So let me get there.
Let's do some research using our own.
Okay, so one of the things that I wanted to point out is this is basically the infrastructure behind it. I don't want to get into technical details of it. This is what we're using. This is the stuff that we're actually doing research on. So how do we convert all that into the right intents and eventually convert into relationship ERDs basically for databases, and then we generate the rest from there. And that's why it's consistent. It's always going to be consistent because every time we generate it, it's going to go through the pattern generator and it's going to be always consistent. This is the managed service, which we introduced in the last 0.3.0 version of our presentation. So all this can be monitored. We're going through Kafka for obvious reasons. This is the document generation, and this is a standard document generation. You can put all the variants, as you can see, inside a XML. Excel. It's going to be automatically converted into our specification, which is in XML, and then eventually you can have a pattern which is in PowerPoint or something like that. It's going to generate reports or anything you want. So that's a document generation process. So this is a little overview of what we're trying to do in the process flow engine. So we are not just connecting to any agents or bots. We are going way down, and you can even have LangChain or N8N or whatever as a single node, which we call activity. So if you think about it from a UML perspective, So these are activities, and you have logic inside your flow. So each activity can be an agent, or it can be a whole agent framework inside it. So we will support all that. You can either use that as an integration, or we'll generate the code for that you can upload into your system if you've already invested in that. Okay, this is how we view this whole model world is going. So our ODB model is abstracted from all of that. So through an AI router, you can go through a AI model serving host, which is some of these. Then you have a model provider, and you eventually have a model. So it's abstracted to a level, so you can change anything. You can either run it on the cloud, or you can run it locally. The advantage of running locally, you control the data. No one gets access to your data. So that's the whole idea. So if you want to run it, you can run it on your data center. You can possibly run it on your laptop even to see end to end whether it's working or not. And then when you're satisfied, you put it on a server with higher levels of models, right? So on your laptop, I can probably go up to, I have 32 gigs of RAM. So physically, I can't go to a model bigger than that. But anything bigger than that, we can run it on the. But the point is, not every model has to go to billions of parameters. That is a complete fallacy. So beyond a certain point, it is basically you're wasting money, you're wasting. So slowly grow the model and see where the most optimal results are, right? Just because some terabyte model is there doesn't mean we need to use it. Okay, so these are different modules, core capabilities and automation, stuff that we're covering through our tool. When it's finished, we are still working on it, of course. Okay, I want to make a small announcement here. This is a summer camp. Okay, if you don't know, I also love cricket. I was playing cricket till a year back in the leagues. And then I had to focus on some more of the AI stuff because I left IBM, and we're doing all this ResearchNet stuff. So anyways, no time for cricket right now, but maybe next year I'll be back. So beware, okay, I'm a bowler, okay? So all the batsmen, beware. So this is Joe Root. So we're collaborating with Joe Root and Adelaide University and a bunch of other professors from the United States, from NYU, there's a professor, Noble Anumbe, from University of South Carolina, and Lance Fortno is also involved. Lance is the former founding dean of, he just retired from Illinois Tech. So we are trying to put together a curriculum which involves cricket at the highest level and AI robotics at the highest level. So that's the idea. So don't want to give out too much. Wait for it, wait for the summer camps to arrive. And I'm also trying to bring back Cactus, which was the only academic cricket tournament. So if you guys are interested in cricket, I hope most of you are, reach out to us. That's our team. I see Abbott sitting right here. As I say, my partner in crime. These are all good crimes, okay? We are all working on AI stuff. Okay, that's my team. These are the three guys I very closely work with from Mexico, Ghana, and the United States. From IBM CAS, Diptam, my head of development, he hasn't graduated yet. He's still doing his 4th year of college, but yeah, he's going to join us formally, totally full-time for us. And lead sports product guy, Abi, is sitting over there. So he's going to tell you a little bit more about the products that we are building. Ronnie, longtime friend of mine, he's my research and innovation partner. And not to last but not the least, Victoria, who's trying to help us with sales and stuff. Okay, this is another new thing that we are starting. This research on what I call pediatric social media shield. We don't want to shield this. So to me, looking at phones is just the next generation how you consume information. So that's not going anywhere. We used to read books. Now you can get most of the information from the phone. So, but you'll notice that they're not talking to each other, they're probably texting each other in between. So that's not a very convenient way of communication. So we want to see and try to understand the psychology and stuff behind how, when it becomes very problematic, right? Not just take phones away and that never works, okay? So they're going to find some phone somewhere to work with. Okay, so having said that, now I'm going to hand the presentation over to Daria. Daria from UIC, and she's going to speak a little bit about her amazing work they do at UIC on Cave 2 with a 3D 360-degree virtual system called Cave 2, right? Thank you.
Do we have slides?
Yes, I can plug it in for you.
Yeah, thank you.
Right.
Thanks, Ron.
Yeah, absolutely. See this little ramp? So hopefully I can plug it in.
Yeah.
Which one? Golden thing? This one?
Thank you. All right. Thanks, everybody. I met Ron and when he organized the IBM group for educational outreach. That was at the time of a pandemic. And the idea for the IBM Global Group was to unite resources and methodologies from theater, design, and technology, and to see how we can invent new things with that methodology in mind. It became global. It was online, on Zoom, during the internet time, and everybody was closed. But the impact of that remains. So what we were trying to do, and as an educator, I'm a professor in the University of Illinois, Chicago. I teach creative coding, and I'm a head and the founder of Computer Science Plus Design program. So the creative coding courses, they exist right now, they're in the 10th years. But at the time, we also had collaboration with Goodman Theater to develop the performance which merges virtual reality and design and computer science. So the classes what we teach, we unite teams of students where we have representation of computer science students and design students working together on the projects. And those projects are developed for the CAVE, Automatic Virtual Reality Environment, CAVE 2. So you see on the slide here is the collaboration and the CAVE. Let me go to the next slide. All right. I'm coming. Here we go. All right. So it's a theater. It's virtual reality theater, and it consists of 72 stereoscopic, passive stereoscopic panels driven by a cluster of, used to be 36 computers, now 6 computers. But when you step inside, you can interact with the virtual reality world. And the projects what we do are, most of them range, from various topics. They inspired by United Nations 17 Sustainable Development Goals, ranging from no poverty to quality education, life on Earth, life underwater, clear water and sanitation, clean tech, sustainable cities and communities, etc. And Ron was very instrumental about promoting, that work, worldwide. We created exhibitions of student projects at the end of each semester. Ron was very kind to streamline it to the partners at the time, educational lines, not only IBM, but the other locations as well, so people can actually watch online. That was during pandemic. Now we open the door to the public. The projects what we do and the students do are really different. They are based on history of electronic visualization laboratory, where this CAVE was invented and built in 1912, and EVL, or Electronic Visualization Lab, has 50 years of history that's specializing in collaborative visualization, virtual reality, data science, advanced computing, networking infrastructure. We do a lot of distributing computing, advancement of tools, frameworks, applications, of virtual reality, and we experiment with visualization and data science that can be streamed, and tools and techniques and technologies for real-time interactive visualization over the advanced networks. Some of the EVL most notable projects are GLOV, Sayer GLOV, Star Wars animation in 1976, the Death Star that was designed using the very first software by Tom DeFanti, who was a founder of EVL, and Larry Kuba, who came as an artist to develop that animation. Cave, original Cave was projection-based Cave in 1992, presented to the world during SIGGRAPH at McCormick Center in Chicago. And Cave 2, it's the next generation Cave, was invented in 2012, which is what you see in the pictures here. So creative coding merges theater, design, and computer science methodology together. It's supported by IBM, as a global educational outreach. Our students are extremely happy, when Ron announces that they will get the badges of the level 1 developer at the end of the successful installation and exhibition every year. And it merges theory and practice of designing and developments of VR project. We use Unity game engine. Students explore the concepts of history of virtual reality in science. That's how we start. And then they develop in a very short and long and a very short steep learning curve, about 8 weeks, projects from sketch to the exhibition. The exhibit, merging topography, interaction, and theater. And a lot of projects in the recent years deal with mental health. So this is a video that...
Hi everyone, my name is Arvind Kumar. I'm a neuroscientist based in Stockholm, Sweden, and I would like to make a proposal for a project for your creative coding course. It's about a navigation task, and we want to use this to extract decision-making variables. It will become more clear in a few slides why we want to do that. So, there's a strong hypothesis which says that the way we make our decisions reflects brain's health. And when I say brain's health, I actually mean it mostly in the sense of psychiatric health. And the belief starts from the fact that, or a lot of observations which say that decision making involves solving certain trade-offs, whether you want to be stable or flexible with your decision making, whether you want to make extra effort or not, whether you want a controlled or automated system, whether you are more going for accuracy or speed, and so on and so forth. And now it turns out that these trade-offs, we can quantify them if we observe decision-making of humans in some realistic familiar tasks. In particular, if we have data about their reaction times and decision history, we can use a lot of theoretical models to extract these numbers. And therefore, this task arises. Just to start with an example, imagine you arrive in a new city and all you have is a metro transit map and you want to go from a location A to B. How are you going to go about this? You have no experience in that city before. All you know is that at a given stop, you have certain options to take a train. So imagine you navigate like this, you reach your destination and your experience, you quantify it in some number. You can take another path and that will give you something else. You can take another one and that will give you some other experience. Now, all you are able to do right now in the beginning is that choose your location, go to a line and reach a destination. And if you play this game long enough, what you will be able to construct is a mental map of this network. You will have a good feeling of which connections are reliable, which are unreliable, and when you should take them. Even if you know this full map, we have deliberately in this example chosen a complex situation. It won't be that easy to create optimal path finding. You will rely on heuristics. you will rely on mental shortcuts to navigate yourself. And this is exactly the key that we want to exploit. If we create some stress-like situations in your navigation, the way you react to those, we would learn a lot about your decision making and also about your brain's health then. So the way we are envisioning is if we have such a task, we can record your reaction time, decision history, and then we can analyze various kind of parameters, mostly using the theory of reinforcement learning. So for this, it is important that we have a task which, a problem which can be gamified so that people can play it at their own leisure. At the same time, the task should be something familiar. Moreover, it should be possible to scale the complexity of the task. And therefore, at least in my head, I'm thinking of this task as navigation in a maze, or perhaps more realistic, navigating a metro transit system. But for American students, that may also be very unfamiliar. Here is a 3D reconstruction of part of the Tokyo transit system. In any case, it's up to you to decide your first step, what kind of decision-making paradigm you want to choose. I mean, in principle, here you can use grocery shopping. But at least for this particular setting of navigation task, I'm thinking of a feed-forward network, something like this, where you have some number of start nodes, some number of layers where you can possibly change. And at each platform or station, you have certain number of incoming connections and outgoing connections. And this is how you can visualize what are your options. The nice thing about this setup is that if you vary these parameters n, k, l, m, etc., you can make this thing arbitrarily complex or arbitrarily simple. You can have fewer choices at each node, you can have fewer layers, and so on and so forth. Moreover, each of these connections, then you can introduce some probabilities, etc. So that will be your step number 2 to realize it conceptually, the basic skeleton of it. Next step would be to simulate movement in it. So once you have decided your metro network, if you wish, then as the subjects are making choices, you need to visualize how they are moving on it. You can try to give them some more feedback or some experience in this. Next, we need to collect the data about what choices the users or players are making. At the same time, we also want, as I earlier said, that we want to create some stress-like situations. So it should be possible to create some sort of perturbations in their choices. For instance, if you have chosen to come to this point and you think that this is actually a reliable connection from here to here, it should be possible on demand that maybe we can create a disruption here so that this path is no longer available or another path becomes more reliable, etc. Step number 6 would be to visualize the choices and performances of the users, how they are behaving or what is their history in this task. Number 7 would be that at the same time you would like to implement reinforcement learning paradigm so that you can collect the decision history and extract the decision-making parameters, something akin to what I earlier said about the trade-offs. Step number 8 would be to compare the players, how they are behaving with respect to themselves in past, or how they are behaving with respect to other players playing the same level and same game. I think this is the minimum that we would expect from such a project, and then this would be sufficient to get out in the field and we can ask players to interact with it. There is a very international team spread across, I don't know, almost 24 time zones because one of my friends, Kenji Morita, he's based in Tokyo and he's really an expert in such decision-making models. I'm based in Stockholm and we have 3 colleagues, Ron, Daria, and Shantanu, who are based in US, Chicago mainly. Shantanu is on the West Coast, so we cover quite a lot of time zones. But we have now expertise in both computational neuroscience, decision making, AI, digital media design, visualization, and so on and so forth. So it's quite an international and highly interdisciplinary team which will be available to support you in building this task. There are some references if you are interested in. You can explore the theoretical background of this particular topic, but we are also available to you whenever you need us. Thank you very much.
So I would like to just kind of speed up a little bit, and all of this presentation is one of the projects that students developing this year, and this was by Arvind. We have a very large team, and I'm just going to scroll over there. Arvind Kumar from Royal Institute of Technology in Stockholm, in Sweden, and then his colleague, Professor Kenji Morita from University of Tokyo, Japan. Ron is in Chicago, and myself is also in University of Illinois, and Dr. Santanu Rus in California. So we have very kind of different time zones. We are in the beginning stages of this project, but the idea is that more and more projects that are being developed addressing mental health, because it becomes a big part of just the consequences, not only from pandemic, but also using social media. And AI can be a big friend, can be a very powerful tool to explore and to employ and to harvest, to put in a service, of humanity in the task of quantifying and studying and researching, how mental health can be advanced and how the protection of the mental health can be employed, and investigated by, students, in the community, by researchers, and just help us as a society and as a culture. So this project in the very early stages, every semester we have about 10 to 15 projects. This year I think we're going to have more than 20. We do exhibitions, they're open to public, and we streamline them, and Ron hosts them on in his Educational Alliance website. So you're welcome to join us, you're welcome to look online, and that's, thank you for your attention.
Thank you, Daria. This is an amazing project conceptualized by Arvind, right? So yeah, looking forward to working with you this spring and summer, and we'll see where we go. Yeah. So we're very excited about that project based on actual research on psychology and stuff. I skipped over my son, actually. Avi, come on over. So we were talking about cricket, and then we skipped over to psychology. Oh my goodness. Yeah, we have more to talk about in cricket. Come on over. Start introducing yourself.
Hey everyone, I'm Abhi. I am a sophomore at the University of Chicago Laboratory Schools. I do several work with AI. I've been helping out with ResearchNet since the onset, and in the past month I've been working on this project called Sports Coaching Assistant, specifically with cricket, but we could definitely expand to other sports. Tracking the ball, and then now we're gonna get to tracking specific movements of the people, analyzing the bones, the joints, how they fit together. And how that can create better analytics, because right now these analytics are only really accessible to top level players, and I would like to see, like in the leagues my dad was talking about, like in the Castle leagues, you should be able to see what went wrong, how can we prepare for the next game at the club level. So let's get started. All right, so I already talked about the problem a little bit, but right now the issue is that manual analysis is right now slow and subjective, and the professional analytics are inaccessible to club level players who don't necessarily need everything, but want to gain a better experience after their match. And feedback from a coach also isn't very quantitative, because it lacks a visual representation of what you can actually see, and those critical match insights end up getting lost along the way. Okay, so this is the product steps we took. So when I started this project about a month ago, I was introduced to YOLO V8, which is the model that we use. When I first looked at it, I'm like, how does this life motto relate to AI? But it actually stands for you only look once. It's a library that you use to, it detects balls in real time. And there's multiple different models. I won't get deep into the weeds with that today, but it can withstand live match analysis, and like be the general library that you use for tracking the ball. And then next step is to train the model specifically for cricket balls. So I found specific data sets online, such as the one on Kaggle. Specifically for cricket balls, there's around 1,800, but I also found others that have around 20,000 images, and this is what you would use to actually train the model to specifically select cricket balls, as right now the existing COCO libraries only detect generic sports balls. So it would detect the seam and be better towards like detecting motion blur and swing and all kinds of stuff that would happen in a real game. And then next, how would we get that to actually work in top level games like the World Cup and stuff? So this is where live video integration comes in, when you're using things like OpenCV, which I'm sure people have heard about, but that would help with the live impact and mapping video frames with things that might be variable, like field dimensions, player builds, player height, and that would greatly help with the trajectory. And then the final step is how do we use these things to build the product, build ResearchNet, and allowing players to track their stats post match with an intuitive GUI dashboard, advanced metrics, more than just the typical where the ball bounced, right? Some more insightful things, and that every statistic should be backed by specific video, which should be easy to go back to. All right. So I won't get too deep into the methodology and exact workflow of the code, but basically I use a multi-strategic approach where I'm not just detecting cricket balls, I'm also looking for color and size for all of the conditions to be met, so we get a more accurate result, or what we call the confidence threshold, which is how confident the model is that it's actually detected the ball. And I'm also creating Java files alongside the Python AI models to help with the GUI and finish out the product in which Python might not be able to reach. All right, so right now we have been able to get the ball tracking to work. So this is an example of it being used. So the 0.99 means that it's 99% confident that's a cricket ball using our model. See, as you can see, there's a bounding box around the ball. It's also detecting the center. So the next steps for this app is to learning how to track the trajectory as it comes out the bowler's hand, calculating the ball in which it points, and then actually providing graphs and data to support that evidence. All right, next. So now we get into the interesting stuff. Instead of just the ball, why don't we track actual people? So here you can see kind of the biomechanics of how the body moves in the length of a full bowling action, and also in a perfect front foot defense, as you can see in that last photo there. So quality fast bowling. I was a fast bowler myself when I bowled. There's four main phases: the run up, the delivery, stride, releasing the ball, and the follow through, all of which are important and should be optimized using this app. And in the past few years, coaches have been able to detect traditional optimization techniques such as knee bracing, where you're keeping the front foot flat, so that and upper trunk flexion, which is supposed to increase torque. And there's different types of delivery, so we can use different points in the bowler's arm and joint to pick up how they're actually holding it and how their wrist is used to bowl different pitches to our American baseball fans. And it's also important that the textbook biomechanical way might not be the best way to teach every single player, because as we know, every player has their own preferences, and not every player is the most textbook. All right. So I talked about this earlier and how we're going to analyze skeletal movements. So looking into some libraries, MediaPipe seems like a good option because it can detect around 20 joints just within the hand itself and around 50 in the entire body. So the more data points you have, the easier it is to analyze the entire body movement and develop high-level analytics. And it's important to recognize that we should only detect movements that are actually possible for the human body. And dynamic time warping algorithms can be used in our product as well, because it's very helpful when you want to review a player's video, specifically to others in the professional database, so you can compare with the pros to better help you. So yeah, that's the solution. You see Glenn Maxwell from earlier, instead of getting out, now he's hitting sixes after using our app. So it's the solution is that we're going to get statistical analytics that are rooted in data and a product accessible to all players that is user-friendly and easy to navigate. So here's my works cited for all the sources I use, and thank you so much for having me. This is a great opportunity. A special thanks to my dad, Ron, and also Diptham, the lead developer, for teaching me a lot about developing this, and also National India Hub for letting me, just a 16-year-old, to present at a big stage like this. So thank you so much. I'll take any questions.
Okay, so April 2nd, we'll have better demo from this. Okay, so I'll take over. We're already running a lot late, so we're gonna switch to. By the way, the food is here. If you have not noticed, I'm hungry, so if you are, just
5 minutes break.
5 minutes break.
So we can eat.
Oh, we take a break?
Yes, we eat.
Really?
People can eat, right?
Okay, we'll take a 5-minute break. How about that? And in the meanwhile, I want to also extend my thanks to Root Academy and Adelaide University, Loughborough University, actually, where a lot of the research has been done on the biomechanics of cricket. Yes, we will work with them at some point once we have something going, and then test it out in the not in international level, but at the county cricket level in UK. That's the idea, and then get some data points from there. Okay, any questions? Always happy to talk about cricket and AI. So let's grab some food, and we'll be back in a little bit.